Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all doing well. Dear students, this lecture is for grade 7, boys and girls both wing, subject science. And in this lecture, we are going to start another chapter, chapter number 8, which is about transmission of heat. This is my 21st lecture, and I am your lecturer, Mrs. Saira Jamal. Introduction of this chapter, transmission of heat. You have learned in class 6 that kinetic energy is the energy of any matter in motion, or in other words you can say that the energy due to motion of a body is called its kinetic energy. You know that all the matters, they are made up of small particles. Those small particles are called atoms combine together to form molecules. So we can say that all the matter, they are made up of atoms. Those atoms or those particles, they have kinetic energy. Also they have potential energy. Potential energy is the energy due to position of a body is called potential energy. So all the atoms, all the particles which are present in an object, that object has different types of energy. The two important types of energies are kinetic energy and potential energy. So the sum of kinetic energy and potential energy which the atoms of an object have is called thermal energy. So the energy of the motion of particle in matter and the energy of the position of the particle in matter is called thermal energy. You can see here thermal energy is the total of all kinetic and potential energy of the atoms in an object. Suppose if we have water in a pot, so the water is our object. All the molecules of water, they have kinetic energy. All the molecules have potential energy. So kinetic energy plus potential energy of those molecules are called thermal energy. Energy due to motion of a body, which is called kinetic energy. Energy due to position of a body, which is called potential energy. So the sum of kinetic energies and potential energy is called thermal energy. Thermal energy can also be transferred from from warm object to the cold object. You can see here that the energy is transferred from warmer object to the cooler object. So this thermal energy transfer is called heat, heat transfer. So when thermal energy is transferred, it is known as heat. The word thermal means heat. Heat is the thermal energy that flows from an object. Which object? From the object which has higher temperature to an object of lower temperature. Now in this case you can see that when the burner is off or when the heater is off, you can see the liquid molecules, they are closer to each other. But after turning on the heater, the water get warmer, the kinetic energy of the molecules increases, the molecules will go far apart from each other. As a result, what will happen? The liquid molecule will turn into the gaseous state. So due to the increase in thermal energy, the kinetic energy, due to the increase in temperature of water, the kinetic energy and potential energy of molecules increases. It means thermal energy of the object or water increases, which causes the molecules to move far apart from each other, and then the molecules or the liquid will convert it into the gaseous state. So a change in thermal energy can lead to a change in phase, like from liquid, it due to high temperature, due to increased thermal energy, due to the heat transfer from the source to the container, the liquid will changes into the gaseous state. Transfer of heat. So, dear students, imagine your teacher has brought packets of dates to distribute it in your class, and the teacher has three options. The first option is the teacher can give a packet of date to the first student, who sit in the first row on first seat, and then the teacher will ask him or her to pass it to the next student, and then to next, and then to the pass on further. In this way, without changing your seat or without leaving your seat, all the students, they will get the dates. Second option is that if the teacher asks the student to make a line and then come to the teacher table and take dates one by one and then receive the date and go back to their seats. The third option is that the teacher and the student all are on their seats, but just the teacher is throwing packet of date to each student, and then all the student will receive the date packets by this way. So there are three ways. So we will discuss the the heat transfer in three ways, which is conduction, convection, and radiation one by one. The first case is actually for the conduction of heat. Conduction of heat means when the molecules, they are not changing their position, they remain on their position, only the heat transfer will take place. So the first option, where the students, they sit on their seats and only they transfer the date. So consider the date like energy, and the students are the molecules which are on their seats, and only they transfer energy or date from one molecule or from one atom to another. So by this way, the heat is transferred from one molecule or from one atom to another, and the molecule, they remain on their position, they are not leaving their position, only a little bit they vibrate on their specific position. So this is called conduction. The first option is related with the which type of heat transfer? Conduction. The transfer of heat from one object to the other is called transmission of heat. Heat energy transfer in three ways, I told you: conduction, convection, and radiation. The first option is related with conduction. The second option is related with convection, and the third option is related with radiation. We will discuss all these three types one by one. First of all, we will discuss the conduction, heat transfer in conduction. Conduction: if one end of a metal spoon is heated with a flame, the other end will also get heated up after a while. If you heat one end of the spoon, what will happen? The heat will transfer to the handle also, and after some time, the handle will also get warm. You can see in this case the fry pan, which is metallic in nature, made up of metal. Mostly the fry pan handles, they are made up of plastic, so that we can easily hold them, and plastic, you know, is bad conductor of heat, so nothing will happen to our hand. But if we will use complete metallic fry pan, so after heating the fry pan, the handle will also, the heat will transfer from the pan to the handle, and then when we will hold the handle, our hand will burn. So this is the case of conduction. If one end of a metal spoon or a fry pan is heated with a flame, the other end will also get heated up after a while. The heat energy is transferred from one end of the spoon to the other without the actual movement of particle. As I told you in the first option, atoms or molecules of the spoon, they will remain on their specific position. They will not change their position. Only you can see here, the molecules, they are not changing their position. They remain on their position. Only they transfer the energy or transfer the heat from one molecule. You can consider the red ball as atoms or molecules. The atom or molecules, they remain on their position after heating. Only they are transferring their energy or transferring the thermal energy or transferring the heat from one end, where we are heating the ball or the atom or molecule with flame. From that end, the heat is transferred to all part or to all the other atoms or molecules, and their position is same. They are not changing their position. So this is, you can consider it the first option, when the dates are transferred to the one by one to all the students. and they remain on their position. So when without the actual movement of particles or without changing their position, the transferring of heat will take place. So this type of transferring of heat is called conduction. Such a mode of transmission of heat is called conduction. It resembles to the example given above in option 1, as I told you, when the teacher gave the dates back to a student, which is on the first seat, and then the teacher asked the student to distribute it or to just forward it to the other students. So the transfer of heat through matter without the actual movement of particles from their position is called conduction. The atoms or molecule, they are not changing their position, and they only transfer the energy. That like it is also same like you can say the parcel game. In parcel game you are only transferring the parcel from one student to the other, and you stand on your position. You are not changing your place, not changing your position, only you transfer the parcel. So same in the case of conduction, it is same like the parcel game, only the date box or the parcel is transferring from one atom to another atom. You can see they are transferring heat. One atom is transferring heat to this one, then this space. So then that transferring of heat takes place one by one, and the molecules or atom, they remain on their actual position. They are not changing their position. So such type of heat transfer I told you is called conduction. Conduction occurs in solid, liquid, and gases, but conduction in solid is better than liquid or gases. Why the conduction in liquid and gases are not as better as in case of solid? I will discuss it in the next slide. In solid, you know that the particles are tightly close to each other. They are tightly packed with each other, and when we heat them, so due to the heat, what will happen? The kinetic energy of these atoms or molecules increases, and then they will start vibration because they will get energy. And due to the energy, their kinetic energy increases, and then the molecule will start vibration. When we heat one part of a solid, the particle gain heat energy, and then they start vibrating faster. During their vibration, they bump into other particle, like they will collide with the other particle, and by collision they will transfer their energy to the other particles and cause them to vibrate fast. In this way, the particles of hot part of a solid transfer heat to those in the colder part. So if suppose the lower molecules, they have more heat, and when they'll collide and they will strike with the molecules which are present above them, so due to the collision they will transfer heat to those molecules or those particles, and then in turn the heat will transfer from the higher part to the lower parts as well, or colder parts as well. Extend your thinking. Why does conduction not occurs at all in vacuum? As I told you that for the conduction of heat, the main important thing is particles, because particles are they remain on their position and only they transfer the heat. Same like I told you the parcel game, they are only transferring the parcel, only the energy or heat. So if there are no particle, definitely there will be no conduction. For the conduction, particles are required. In vacuum, there are no particle. No particle means no conduction. So heat transfer by conduction and convection works by particle colliding and transferring heat or energy. As there are no particles in a vacuum because there is no air over there, so heat transfer can only occur by radiation. So in vacuum, the transferring of heat will take place only by radiation, which we will discuss in the other topics. So this is because radiation involves electromagnetic waves, not particles. In vacuum, there are radiation, electromagnetic radiation. There are no particles in vacuum, and as therefore able to transmit heat across a vacuum. So only radiation can transfer. You can see these are the waves or the radiation which can transfer heat in vacuum. but conduction does not takes place in the vacuum because there are no particles, no air in vacuum. So no conduction will takes place in vacuum. Conduction or the transferring of heat only takes place through radiation, not through conduction. Radiation, I told you, we'll discuss in the next slide. To understand the conduction, let us do an activity, activity 8.1. For this activity, you need a metal rod or a knitting needle. You can use a metal rod or a knitting needle, a cork in which you have to fix one end of that knitting needle, and you can hold the cork so your hand will not burn. And then you need a candle, and what we have to do, you have to fix one end of the knitting needle in a cork, and then turn on the candle and put some wax on three position of that knitting needle: position 1, position 2, position 3. On three position on the knitting needle, put the candle wax, the melted candle wax, and let the wax to get cold. Light the candle, burning candle will melt and change into liquid wax. Drop this melting wax onto the rod at three different points. Then let the wax to cool. When the wax cool down, then hold that knitting needle along with wax on the candle. Heat the free end because other end is in your hand. So heat the free end, which is free end of the rod on the candle. Note the time when the wax at the free end melt. Then note down after some time this wax will melt down, and then this wax will also melt it down. Note down the name that after how much time the wax start melting. On which point will the wax melt first? Obviously the wax which is at the free end, it will melt first. Then the molecules or atoms or particles of this knitting needle will get warm. Their kinetic they will absorb heat from the candle. Their kinetic energy will increases. They will start vibration. Then they will collide with the other particles and then will transfer heat to the other particle. Then this wax will start melting. Then same will happen to these particles. Their kinetic energy will increases, and then they will start vibration, and then they collide with the particles at this side, and by this way all the particles in the knitting needle, they due to the heat of the candle, their kinetic energy will increase, or in other words the thermal energy will increase, and which in turn will causes the melting of the wax which we put in before on the knitting needle. So this confirms that the conduction of heat takes place, or transferring of heat takes place through the particles which are present in this metal or in the knitting needle. Good and bad conductor, the different materials conduct heat at different rates. Some materials are excellent conductor of heat, and some are normal conductor of heat. Some are bad conductors of heat. So on the basis of the conduction of heat, we have good conductors, bad conductors, and semiconductors are also over there. So material which allow heat to flow through them easily are called good conductor of heat, and mostly all the metals, they are good conductors of heat. Materials which do not allow heat to flow through them easily are called bad conductors of heat, or they are also called insulators. Solids such as wood, glass, plastic, styrofoam, etc. are bad conductors of heat. And all liquid and gases except mercury. Mercury is liquid, but it is a metal. So metal, I told you, are good conductor of heat. It is a good conductor of heat. That's why we are using mercury in thermometers, in mercury thermometers. But all the other liquid and gases, they are bad conductors of heat. Silver, gold, copper, steel, and seawater, because it has salt, dissolved salts in it, which make the seawater good conductor of heat. And the bad conductors are rubber, glass, oil, diamond, wood, they are bad conductor of heat. Styrofoam is also a bad conductor of heat, and when we keep sandwiches or burgers or pizzas in styrofoam, so as they are bad conductor, so the pizza, the burgers, sandwiches, they will remain warm for a long time because styrofoam will not allow the heat to move out from the this box, and it will not allow the cold air to move inside the box. So that's why we say that they are bad conductor of heat and will keep the food warm for a long time. Good conductors: silver, copper, aluminium, iron, mercury. Mercury, I told you, is a liquid but is good conductor. The rest of all are solids and metals. All are metals. Even mercury is also a metal. Insulator are air or any gas. Cork, which is made up of wood, glass, plastic, wood. They are bad conductor, and we can also call them insulators. Now to understand about the conductors, good conductors of heat, let us do an activity. Some materials are good conductor of heat and some are insulator. For this, take some hot water in a beaker. Take some hot water in a beaker and then take a steel spoon, a glass rod, a plastic scale, a wooden scale, and a piece of thick copper wire in that warm water or hot water. Dip one end of each of these in the hot water, wait for 2 to 3 minutes, and then touch the other end of each article with your finger. After 2 to 3 minutes, touch the ends of these objects and check which one is warm or which object will get hot or warm. Definitely the metals, they will get warm up because they are good conductor of heat, while the rest of wood, glass, plastic, scales, they are bad conductor of heat, so nothing will happen to the temperature of these objects except the steel spoon, the steel spoon and the copper wire, as they are metal, so their temperature will increases or they will get warm. The remaining objects like the plastic, glass, and wood, nothing will happen to those objects. It means they are bad conductors of heat. Which one become hot? Conductors of heat, and which ones do not? They are called insulators or bad conductors of heat. Why metals are better conductors than non-metal? All solids, if they are metals and if they are non-metals, they are made up of tiny particles. I told you those tiny particles are molecules, means atom and atom combined together to form molecules. But some solid conduct heat better than others, and let us suppose a metal and a plastic spoon be in hot water. Which one is a good conductor of heat, metal or plastic? So it's understood that the metal are good conductors of heat, and they are better conductor. When both spoons receive heat energy, the particles, atoms or molecules at the hot end of each spoon vibrate fast and bump into neighboring particle. These particles transfer heat energy to next neighboring particle. As I told you that in case of the metal, the molecules, they are transferring heat. And one more thing is that for the conduction of heat and electricity, free electrons are important. Actually, free electrons are responsible for the conduction of electricity by the metals, and also the conduction of heat. You can see here electrons are moving, the molecules are, they are transferring electron, they are transferring heat or thermal energy. You can see here transferring by amongst each other. So those transferring of free electrons and heat make the metal good conductors. While the non-metal, you can see glass, there is no conduction of heat or no conduction of the free electrons, transferring of free electrons. Semiconductor are those which are also transferring the heat and free electrons, but on lesser extent. On greater extent, metals transfer free electrons and heat on greater extent. Particles in metals are more closely packed together than non-metal. Metals can transmit heat energy more readily, more fastly, or with greater speed than non-metals like wood and plastic. The presence of free electron, as I showed you in the previous slide, the free electrons also free electrons, the electrons which are present in the outermost shell and they are less tightly bound by the nucleus are called free electrons. As the nucleus has no greater pull for those electrons, so those electrons can easily move out from the atom. So due to the presence of free electrons, which also speed up the transfer of heat in metal, when the metal spoon gets heated, the free electrons gain kinetic energy and then they move farther toward the colder part. And then definitely by this way they are transferring heat, they are transferring free electrons, and due to the vibration of the particle, the moment of free electron will also takes place. So by this way you can say that metals are good conductor of heat than non-metals. You can see these are the free electrons which can easily pass to or transfer from one point to another point, or from warmer point or a hotter point to the colder point. Then extend your thinking. Many fast food restaurants pack their hot sandwiches, pizzas in styrofoam boxes instead of wrapping them in ordinary paper. Why is the styrofoam used? The styrofoam is a good thermal insulator. As I told you, it is a bad conductor of heat and making the container easy to carry as well as keeping the food at the temperature it had when filled into the container, whether hot or cold. As I told you, that styrofoam is a bad conductor of heat and it would not allow the heat to go out from the inside of the container to outside and will not allow the cold air to come from outside into inside of the container and then intend to keep the food warm for a long time. So styrofoam boxes are good for keeping sandwiches and pizzas and burgers. For that those purposes, they are good in that sense. Conduction in liquid and gases. The process of conduction in liquids and gases is very slow as compared to solid metal. The reason is the particles, as you can see that in solid the particles are tightly packed with each other so they can easily transfer the heat or free electrons to each other or among them. While in case of the liquid, the particles are a bit farther from each other, so the transferring of heat and free electron is a little bit slow. Excuse me, slow. While in gases, the particles are too much farther apart from each other, so the transferring of heat and like free electrons is not possible. That's why the heat conduction in liquid and gases is very slow. And water and air are bad conductors of heat. The process of conduction in liquid and gases is very slow as compared to solid metal. The particles in liquid and gases are not held closely together. The particles have less chances to bump into other particles, means to collide with other particle in liquid and even and lesser collision in gases. That is why the transfer of heat energy from fast moving molecule to neighboring molecule is very slow. So water and air are bad conductors of heat. So dear students, I hope you understand this lecture about conduction. Still, in application of conduction and an activity is left. Inshallah, we will do that activity in application of conduction, and then we will do also a next type of transferring of heat, that is convection, as well in our next lecture. So till then, take care. Allah.